Hello everyone, I thought I'd shoot a quick video um, giving you an overview of the pre-lab for the kinetics experiment that we're going to be working on virtually. The title of the experiment is Determining the Rate Law of Crystal Violet Hydroxide Ion Reaction. It is an experiment that requires a lot of work with data workup, calculations, graphing, drawing conclusions. So it's very important that you prepare for this lab by completing this pre-lab, but first carefully reading pages 91 through 101. Those pages provide necessary background information and some important examples of the calculations that you'll have to be doing. The pre-lab is on pages 113, 114, and I wanted to go over questions 2 and 3 with you. The pre-lab will also require some graphs, specifically in question 2. Question 2 talks about reaction of decomposition of nitrogen dioxide, where NO2 breaks up into NO and oxygen. And the data provided here includes 2 columns with 2 additional columns that are left blank. The first column here lists time in seconds, and second column concentration, brackets stand for molar concentration of reactant NO2 in moles per liter. Obviously, because NO2 is a reactant here, we see that concentration is decreasing as time progresses because NO2 is being converted into products. Most importantly though, for this question, it says calculate the natural log and the reciprocal for each of the value of NO2. Instead of calculating these values using a calculator, what I think you should do, and I strongly recommend you do it that way, you're going to open Excel spreadsheet and you're going to enter time on the left hand side and concentration of NO2. These are the 2 columns directly copied from the table in the pre-lab. You're going to have 4 entries for each. And then you're going to calculate, have the computer have Excel calculate values for each of the natural log of concentration and 1/over concentration. I would point out that in Excel it's possible to calculate one value, like for the first concentration rather, you can type in equals ln, and then in brackets put value of NO2 concentrations, hit enter, it will calculate it for you. And then you highlight it, put your cursor in the top right corner, a little black cross should be seen, and then you drag it down and it will automatically calculate the entire column for you. It's a lot less time consuming to calculate it that way rather than having to do every single entry manually. For the experiment itself, you will be provided with data sets that may contain up to 120 data points. You certainly don't want to sit there and do each one data point individually, so you want to be able to do the entire column calculation all at once. And then the same thing for 1/over NO2. So you're going to take concentration of NO2, you're going to type equals 1/over, and then name and number of the cell in which NO2 concentration is found, hit enter, and you'll have your reciprocal, and then you can just drag it down and find values for all of them. Then, using the data you will have in Excel, you're going to create 3 graphs. First graph is going to be concentration of NO2 versus time. Second graph is going to be natural log of concentration versus time. And the third one is going to be 1/over concentration versus time. For each of these 3 graphs, you need to do scatter plot with a linear trend line. You don't need to set y-intercept to 0, so do not do that. Instead, ask the computer to find what's called R-squared value for each of these graphs. Why do you need to find R-squared value? Well, the goal here is to find the order of reaction with respect to NO2. And here you have to figure out which of these 3 graphs provides best linear fit. And to make that judgment, you need to know R-squared value. In math, R-squared is a statistical parameter that allows you to figure out in which graph all data together fit the, in this case, linear trend line the best. So you'll need to find the graph whose R-squared value is closest to 1. So if R squared value is closest to 1 for this first graph, it means that concentration versus time is the best linear fit. If R squared value is closest to 1 for the natural log of concentration versus time, it means this graph is the best linear fit. Same for this. How does knowing which graph is the best linear fit help you find order of reaction? Well, this is called integrated rate law approach. And the lecture, hopefully you've discussed the fact that if concentration versus time happens to be linear, it means that graph is zero, the reaction is zeroth order. If natural log of concentration versus time is the best linear fit, order of reaction is expected to be 1. And finally, 1 over concentration versus time. If this one happens to be the best linear fit with R squared closest to 1, that means order of reaction is second. So that's how you should do question 2. Now to question 3. In question 3, the data provided is very different. So hopefully you're looking at page 114 now for question 3. Here we're talking about the reaction between two hypothetical reactants A and B. And here the data given to us is very different than in question 2. Here we have two trials, and we're given concentrations of both A and B in both trials, as well as values of initial rate. According to the table given here in the question, concentration of reactant A in trial 1 and concentration of reactant A in trial 2 are both equal to 0.01 moles per liter. For reactant B, though, concentration of B in trial 2 happens to be, I think I got it the other way around. Make a correction. So concentration of reactant B in the second trial is 0.02, and concentration of B in trial 1 is 0.01. So how can we use these data to figure out order of reaction with respect to reactant B? Well, here we need to use what's called method of initial rates. Method of initial rates is associated with one important word. That word is ratio. So we need to write rate law for both trials 1 and trials 2 and then create a ratio. I haven't quite written the ratio yet, but what I did over here is I wrote the expression for rate law for trial 2. For trial 2, rate would equal rate constant times concentration of A in trial 2 in order of M times concentration of reactant B in trial 2 in order of N. Similarly, in trial 1, rate would equal to rate constant times concentration of reactant A in trial 1 in order of M times concentration of reactant B in trial 1 in order of N. So now watch what happens if I divide my rate in trial 2 by rate in trial 1. I make the ratio, right? So ratio is the key word here. Ratio of two rate laws. Making a ratio like this will allow me to eliminate or cancel several things. So first let's write the numerical values. So concentration of reactant A in trial 2 is 0.01 and concentration of B in trial 2 is 0.02. And then for trial 1, okay, concentration of A is still 0.01 and concentration of B is also 0.01. So doing this, you can see, will allow me to get rid of several things. First of all, rate constant can be canceled, and second of all, A can be canceled because A is kept at the same concentration. So this is not a coincidence that in the original data table here in the book, concentration of A is kept the same for both trials. This is done so A can be canceled out here. Now, what else are we given here in the problem? Don't forget the last row. It says rate, moles per liter per minute. So we're given initial rates. These are initial rates right here, rates at the moment in time when reaction first starts. So we can then, for trial 2, it's 10.5. and then for trial 1 it's 5. So then we can find numerical value. 10.5 divided by 5, it would be something like 2.25 maybe, or something like that. And then the key is, what is 0.02 in order of n divided by 0.01 in order of n? Well, hopefully you can see it's 2 in order of n, right? So we end up with this equation here, 2.2 in order of n equals 2.25. So how do we find n from here? This is actually more of a math question rather than chemistry question. What you will need to do, and by the way, this may not be the exactly correct number, I just guesstimated it. It's probably different, but point is, you can use a calculator to find 10.5 divided by 5, and that is equal to 2 in order of n. In order to find value of n, what you need to do is you need to take logs of both sides. Now you can either take natural log of both sides or log with a base of 10, it doesn't matter. So if I use natural log, it will equal n times ln2 equals natural log of 2.25. And then you can find n from there by dividing this one by that one. What you need to do for the pre-lab is to make sure you show me the complete setup. Very similar to what I did here. How you write rate laws for both trials 2 and trial 1, how you make a ratio, how you get rid of K and concentration of A, and how you end up solving for n, including the logarithmic equation setup and solution. This part is absolutely required for full credit. So hopefully this helps you deal with this pre-lab. And pre-lab should include all the work included and all 3 graphs in Excel. Should be submitted on Canvas.